Good day, everyone. This is Mass Intelligence Tutorials, and we'll continue from where we stopped in our previous video on product rule under differentiation. In the previous video, we talked about product rule, how you can find the product rule, or when you have multiplication of two different functions being multiplied together, and you are trying to differentiate. The best approach is to just go with product rule. And we also discussed the formula which we use to solve that kind of problem, and the various approaches in order to solve that kind of problem. And in case you have not seen that video, probably I'll drop it in the description below, and you can check it out before you commence this tutorials or this video for today. Okay, basically today we are going to be looking at how you can solve for using product rule, or how you can differentiate functions at which you have three different functions being multiplied together. So when you have like three different functions being multiplied together, how can you find the product rule of three different functions? The product rule of two functions multiplied together is one in the previous video, but for this video we are trying to do the product rule of three different functions that are multiplied together. So let's look for an example and then let's fire from there. Okay, let's see. We have an example here, which is let's say is equals to so we have something equals to let's say example, let's say you have y is equals to, sorry about that. Okay, let's say you have y equals to let's say x squared. Okay, x squared, let's see, sorry, x squared, let's say sine x ln x. I want to solve this problem. X squared sine x in x. We are trying to solve this problem. So how do we solve or tackle this kind of problem? Now if you look at it, you have one function here multiplied with another function multiplied with another function. So how do you solve that kind of problem? Now, in a normal formula for product rule, we have something like y equals to uv prime, right, plus v u prime, something like this. Yes. So what about when you have three different product rules? So how can you tackle that kind of problem? So in order to tackle that kind of problem, what do? You have another formula. There's a formula for that, which is y equals to u prime. Let's say we have three functions u, v, and w. Let's say we have that u prime v w id plus v prime u w plus w prime u v. So this is the formula we are going to use today to solve the approach of three different function multiplied together using product rule. Okay, so from our question, we have what we have our u to be x squared. I use x squared, and you have our v. Our v is sine x, and we have our w. Our w is at ln x ideal. So we have this. So what will be our du, which is our du dx? Our du dx will be 2x squared, right? And our dv dx will be which is our v prime, will be cos x, and our w prime, which is w dx, will be what, 1 over x. So from this, now we can now input this into our formula and also get our final solution. So inputting this problem into your formula, what do you have? You have u prime, and this is u prime here, which is 2x squared, and multiply by v and w. V is sine x, you have sine x, multiply by w is ln x, you have ln x id, plus what is your v prime? V prime is cos x. Can you see now? You have cos x id now, multiply by what is u? U is x squared, So we have x squared. And what is w? W is ln x. We have ln x idea now. Plus for the third one here, we have w prime. And what is w prime? W prime is ln x. W prime is 1 over x rather, multiplied by what is u and what is v? U is x squared and v is sine x. Are you getting it? So from here we have equals to x can cancel one x here, and here we can also, so writing this, you have x squared, 2x squared, we have ln x sine x plus, this one gives me, I can write it as x squared ln x cos x plus this last one here, since one x has cancelled one x, you have a 9x sine x. So having this now, from here we have this. So from this place now, what is common to everything here? X is common. So what do we have left here? We have 2x. Having left here ln x sine x plus, what do you have left here? X ln x cos x now plus sine x, which is what we have at that ending here. So if you look at after factorizing, we have this, and this is our final answer for that problem. So when you have three different functions multiplied together and are trying to differentiate using product rule, you just use the approach of that new formula that is given in this video. So through this, you can solve future examples and also have more understanding when you are confronted with such problems. So this is where I'll stop for today, and don't forget to subscribe and also share to those who need it. So see you in the next video.